Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how to prove that vertical angles are congruent. Now, we are told that they're the same, but remember in math, just because someone tells you something doesn't mean it's true. We want to be able to prove it for ourselves and know that vertical angles are congruent or the same. So we are going to start by being given two vertical angles, angle 1 and angle 3, and we want to show that they're congruent. So we're going to prove this using our two-column proof, just like we have been. So we have our statement side, then we have our reason side. Now, before I write out this full two-column proof, what I want to do is kind of voice out, how do we know that these are the same? Well, let's take a look at these vertical angles here. They gave us angle 1, 2, and 3. Obviously, they gave us angle 2 for a reason. Well, look at this. Angle 1 and angle 2, well, those two there, let me use a different color. They create a linear pair, right? These two lines, or these two angles are on a straight line. So we know they equal 180. Similarly, we know that angle 2 and angle 3 also create a linear pair, right? They also are on a line. Therefore, if they both create a linear pair, the definition of a linear pair says they equal 180 degrees. So if they both equal 180, 1 plus 2 and 2 plus 3, well, I can just subtract out 2 and show that 1 and 3 are the same. So that's how we're going to go about this proof. That's logically how it makes sense to me. Now, for you, you might go about it a different way. But for me, that's what I'm going to do because that's how I think of it. 1 plus 2 and 2 plus 3 are both going to be lines because they're like a linear pair. So they're both going to be 180. I can subtract out 2 and show that they're the same. So let's do that. So I'm going to start here with our given statement. So angle 1 and angle 2 are vertical angles. Now that's super important because that means that they're right across from each other. And that is given to us. Now let's take a look at this next part. Well, in our explanation, we said angle 1 and angle 2, they make a linear pair. And what makes them a linear pair is the definition of a linear pair. They're two angles that are on a straight line, right? So angle 1 and angle 2. Oh, this is angle 1 and angle 2. This should say angle 1 and angle 3. Angle 1 and angle 2 are a linear pair. How do we know that? Well, by the definition of a linear pair, two angles that make a line. And we know that definition based on our notes from the other day. So angle 1 and angle 2 are a linear pair. Well, what does a linear pair mean? Well, that means that the measure of angle 1 plus the measure of angle 2 is going to equal 180. And that's by the linear pair theorem. Okay, and so then similarly, if angle 1 and angle 2 are a linear pair, angle 2 and angle 3 are a linear pair. So I'm going to use the same thing. Angle 2 and angle 3 are a linear pair. And how do we know that? Well, that's by that definition of a linear pair again. Linear pair. And then that means that the measure of angle 2 plus the measure of angle 3 equals 180 degrees, again, by the linear pair theorem, which says that those are going to be equal. Now, what I want you to notice is how both of these equal 180. So because they both equal 180, we can set them equal to each other. And the reason why we can set them equal to each other is by the substitution property of equality. So that's what we're going to use here is the substitution property of equality. Fantastic. So we do that substitution property of equality. I can get rid of this measure of angle 2 from both sides and end up getting the measure of angle 1 equals the measure of angle 3 by the subtraction property of equality. And then lastly, what we want to prove is not that just that they're equal, but that they're congruent. So that means our last step is that angle 1 is congruent to angle 3. And how are they congruent? Well, that's by the definition of congruence, right? The definition of congruence says that they need to be the same shape and the same size. Well, we just proved they're the same size and they're both angles, which makes them the same shape. Therefore, if they have the same measure, they're congruent. And that's how we would prove there that vertical angles are congruent. Because they both create a linear pair with the angle in the middle, we can then set those linear pairs equal to each other and subtract out that overlapping angle of angle 2 and show that angle 1 and angle 3 are equal. And that's how we prove that. Please check out the next video in which we cover how we can prove that alternate interior angles are congruent, or the following video where we prove that the interior angles of a triangle add up to 180 degrees.